is mean value theorem. Okay, we have a couple of theorems to talk about in this lesson, or in this unit, one of which is mean value theorem, or as you might hear, MVT. You know, we already have IVT, right? Intermediate. So we're going to talk about MVT, mean value theorem. Now, we're going to look at some information and kind of do some discovery here, I guess is what they call it, but use the graphs and questions below to explore conclusions to the mean value theorem. So we have 4 graphs. Step 1, draw the secant lines for each figure on the given intervals. What are secant lines? Okay, it's going to go through 2 points, and so it's not a tangent line, it's a secant line. It goes through 2 points of the graph. Now, what we're going to use is the dots provided and draw in 1 or 2 secant lines depending on what is provided. So, as we look at figure 1, where's your secant line going?
1, 6, 2, 9, 4.
Okay. And this is where, if I could use a ruler on the BenQ, life would be grand. Actually, I don't really need the arrows. Oh, I took the whole line. There we go. We're going with it. There's my secant line. Good enough, right? And, okay.
Does it matter if it has arrows on the?
No, it doesn't. Okay, figure 2. Where's my secant line going?
2 points.
Through the 2 points. In other words, we're specifically looking for where the points are. We're not making our own points. We're specifically looking for where the points are. They have them posed for a certain reason. Okay, figure 2. Notice we have 3 technical points here, yes? That one on the bottom is a hole. And so we're actually going to draw 2 secant lines in this case. Both secant lines involve the middle point. So we're going to use a secant line from 1, 6 to 5, 4. It's not a very good line. And using that same center point, drawing from, what is that, 5, 4 to 10, 6. And I don't know that you have to necessarily label them secant, but might be helpful. And then on figure 4, from point to point, it's going to go very near the actual equation, isn't it? Or actual function. Okay. You got your secant lines?
That was really bad.
I know, mine aren't great either, but we're going to go with them. Okay, what's 2? Are there any points on the graph of each function where the tangent line to the graph appears to be parallel to the secant line you've drawn? So draw a tangent line or lines between the endpoints of the given interval, if possible. Let this point of tangency be called x equals c for each figure.
Maybe figure 4. Yeah.
What are you seeing in figure 4?
It should be like really close together and parallel.
Okay, so In other words, the idea is there's going to be a tangent line that is parallel to the secant line. Difference is the secant line is to the left of the graph. The tangent line is going to be
Right.
to the right of that portion of the graph at least. Okay. Where is that tangent point at? That's a really, it's kind of hard to just eyeball it, but you see what's happening here. Those of you using rulers, you might be able to make it a little bit, be able to tell a little bit better. But I will tell you, I have my C value at 4. So what that's telling me is that my tangent line, the tangent line is supposed to, or my tangent line went about through there.
I see it.
You see what you're supposed to be doing? Something like that?
It's okay.
And see, it says let this point of tangency be called x equals c. I have mine labeled as c equals. So, or c1, because sometimes we'll have more than one. So c equals 4 there, because that is the point where it is tangent to the curve. Now, could yours be slightly off of that? It could be. But officially, that's where it is. Okay, what else do you see? Oh.
Maybe on figure 3.
What are you seeing on figure 3? My blue lines are my tangent lines.
The first one to the left, right on. It looks like
I would say 3. Yeah.
Yeah. So here's my secant line. Can you see a tangent line up above it that's going to be parallel? And I do have it 3 in my notes. So there's going to be a tangent line in that area. Okay, so there's a tangent line.
Figure
6.
What, Doug?
About 6.
What about at 6? Notice I called that C1 equals 3. Because there's going to be another C in this particular problem. And it is at 6. That does not look very parallel in my book. Well, something like that. So I have that as C2 being 6. This is where if I was using a ruler, I could be a lot better at this, but I'm freehanding, so you're getting what you get.
I don't think there's any on figure 2
And why not?
because there's the point.
The
It
cusp.
doesn't really help. The sharp.
The sharp point, the cusp, exactly. Because of that point there, you're right, there are none on figure 2. Okay, what about figure 1?
Like
Yeah, I'm thinking like
2 and
it's
a
in between
half.
like 2 and 3.
Mine in my notes is at 2.5.
Stop talking.
Another tangent line there. Exactly. My notes say 7.2. So that's that 7 1/4 type area. You guys are definitely getting the idea of this, aren't you? Because you're throwing out the numbers to me, so. Okay. And here's, I'm going to take it as when my lines all kind of look parallel on each respective figure. Not bad. Okay. So that was step 2, or question 2. Are there any points where the tangent line appears to be parallel to the secant line? And that's what we did, right? Parallel to the secant line. We called those our C values. Okay. So 3. Oh, I think we've already done 3.
Yeah, we did 3.
I didn't realize. I forgot what 3 was. For each figure, estimate the value of x equals c, where the tangent line is parallel to the secant line, or explain why it is not possible. So, on figure 1, we said that C1 is 2.5, and we said that C2 is 7.2 is what I wrote down. On figure 2, we said that there was none, and that's because there is a cusp.
I'm sorry, sure. Could be either.
On figure 3, we had C values at 3 and at 6. And figure 4, we had a C value at 4. Okay. Honestly, I don't know if we really needed to write that information down there since it's mostly on the graph at this point. I just wrote cusp up there, so. Okay, question 4 when you're ready. Think about it first.
What interval?
1 and 1.
The interval being just what's shown in the graph
Oh, okay.
is the way I interpret that one. So this question is about continuous.
Not 3. It's not 3.
1, 2, and 4.
Okay, so definite agreements of not 3.
Yes.
And here's the idea, continuous. And I have to be kind of careful about this at this level. But my basic definition of continuous back in like algebra 2 is, can I put my pencil down and trace it, right? Without lifting it up. Figure 3, I can't do that, but are we good on the others?
Isn't
Yeah.
that a jump discontinuity?
You could call it that, yes.
Just
That
if
would be
they were
one
both
name of it.
Then it'd be continuous, right?
Now, no, it still wouldn't be continuous because there's a gap between them.
Oh.
So, now I have it listed in my notes as F, G, and K, but 1, 2, and 4 are correct too. So, F of X, G of X, and K of X. If you want to use 1, 2, and 4, I'm good there. Which functions are differentiable on the given interval?
1, 4.
Oh, wait a minute. Given interval.
It's 1, right?
Okay, wait. I just realized, based on looking at this question, when I define the interval is going to be from the point to the point. Okay, from the point to the point. So like in this, on figure 1, it's from this point to this point. Figure 2, this point to this point. Figure 3, outside point to outside point. Figure 4, this point to this point.
Not figure 3.
Okay. Figure 3 was not continuous, definitely not differentiable.
Figure 1, yes.
Figure 1's the only one.
That I'm
Figure 1 is differentiable. Figure 2 is not because of the cusp. Now,
No,
But-
figure 4.
figure 4,
It doesn't also have a cusp.
if we are just looking
But you're
from
looking from that point to that
point to point,
So yes.
if we are just using that given interval, which, and that was my mistake on the definition of interval, because, so that would be f of x and k of x. Okay, so, which are not differentiable, well, that's a obvious at this point, right? Explain why. So,
Cusp will be here. Two.
I'm putting mine over here because I didn't blow up this screen. So, okay, so g of x cusp at, what'd you say?
Is it 5?
5. Or maybe you didn't say that, but my brain was looking for that. Cusp at x equals 5.
Maybe G is.
H of x,
Not because of, and I put.
not continuous at x equals 5, and I actually have h of x is not continuous, and I have parentheses underneath it, jump at x equals 5. So not continuous at x equals 5 because there is a jump discontinuity. Okay. Now, you'll notice in all of these, we talked about the secant lines and the tangent lines, yes? And the relationship here, this was our discovery as we get ready to talk about the actual mean value theorem on the next page. But the idea of the secant line and the tangent line being parallel. Okay? That's what our mean value theorem is going to talk about. So, we have two theorems on this next page. Mean value theorem is our primary theorem here, okay? Rolle's theorem is just kind of a special case of that. But mean value theorem, fancy speak. If f is continuous on the closed interval a to b, closed interval just means a and b are included, okay? If f is continuous on this interval, and then differentiable on this interval. And it's never going to say differentiable on the closed. It's always going to be on the open, okay? On the open interval a to b, there exists a number c in a and b, and this says such that f prime of c equals f of b minus f of a over b minus a. Now, a couple of different ways to think about this.
Isn't that like midpoint?
No.
Never mind.
Think f prime of c. What does that represent? F prime of c?
Slope.
Slope, which is also known as IROC. F of b minus f of a over b minus a is slope also, but slope between 2 points, right? AROC. So the idea that f prime of c is IROC, and the f of b minus f of a over b minus a is AROC. So the idea that the tangent line is equal to the secant line there. The slope of the tangent line is equal to the slope of the secant line. Graphically, tangent line is parallel to the secant line. Okay? So those are the different pieces we have here. Trying to think what kind of hints do I want to put down for you. So the idea right here, we already talked about this. IROC is equal to AROC. The idea right here, the tangent line is parallel to the secant line. So it's, I can say f prime of c. You guys remember the parallel line being the two vertical pieces? That represents parallel. Is parallel to f of b minus f of a over b minus a. Okay. And actually, this shouldn't be f prime of c. This should just be f prime of x, I guess. Okay. So the slope of the tangent line is equal to the slope of the secant line. One way or another, that's what you need to walk away from this realizing. Okay. Slope of the secant line excuse me, is equal to slope of the tangent line. Okay. That's your mean value theorem. We will, as we go on, look at ways to use it, ways it applies, and things like that. But for right now, I'm just trying to get the idea out there. Okay? So that's your mean value theorem that we'll have to work on knowing. Now, Rolle's theorem. Okay, I have it written in my notes that it's a sidebar of MVT. Okay, it's a sidebar or a special case of MV, of mean value theorem. Side of, not what I was trying to say. Sidebar of MVT, or if you prefer to say, it's a special case. With that in mind, a lot of the pieces are going to read the same. Okay? Let f be continuous on the closed interval and differentiable on the open interval. That's the same old, yes? Then, so continuous and differentiable, if f of a equals f of b. So if f of a equals f of b, that's saying the y values. F of a is a y value, f of b is a y value. That's saying if the y values are equal, then there exists at least one number in the interval where the derivative equals 0. Okay? Right here is a, yes? Right here is b. Where are f of a and f of b? F of a and f of b are this horizontal piece here. Okay? So this is a special case that if f of a and f of b are the same, so if they have the same height, that means the secant line is going to be horizontal. If the secant line is horizontal, what's that mean about the tangent line? It's horizontal, and what's the slope of a horizontal line? 0. Okay, so the Rolle's theorem is the specific case when these two are equal, thus creating a horizontal secant line and thus horizontal tangent line. Okay? So if these conditions hold true, then there is at least one number between A and B so that the tangent line is horizontal. Or in other words, the slope equals 0. Whatever way you want to state that. Okay? So right here you've got the slope of the tangent line is 0 and the slope of the secant line is 0. Did I write anything else in here? Yes, I said this, but the idea when your y value equals your y value, so if you think like y1 equals y2, those y values are the same. Okay, that's your special case. As I said, we're going to go work and talk about using those here next. Now, important note, both Rolle's theorem and the mean value theorem guarantee at least one value strictly on the open interval. 2 questions to ask just to get us thinking. What is the difference in conditions between the mean value theorem and the Rolle's theorem? What? Okay. Rolle's is horizontal, so the slope of the secant line is 0. It has to be. When we did all of those on the front page, we had all kinds of slopes, didn't we? Okay, that was just the general mean value theorem. Specific Rolle's theorem, it has a secant line where slope is 0. So Rolle's slope of the secant line equals 0. Now, the place that you'll see this used kind of relates to this second question. What does Rolle's theorem tell you must exist on a given interval?
2 points that equal the same. I don't know.
Go more than that.
2 points have the same line.
Okay. Well, the 2 points have the same y,
Like a,
and that
yeah.
causes a slope of the secant line to be 0, right? Which causes the slope of the tangent line to be 0. A slope of a tangent line being 0, what happens at that location? What? There's a max or a min. Okay? That's why I was like, okay, if I take you through this, you'll see it. So yeah. What does it tell you? And here's the key. It says must exist. Because that slope of 0 must exist, a max or min. I have the word extrema in my notes. Remember, extrema is our fancy word for maxes and mins. Okay? And extrema must exist. So extrema, which is a max or a min, must exist. Okay? And that's because your slope is 0.
This is fun. I love drawing graphs.
I'm not sure on this next part why she didn't just draw the initial points in for us. I don't know. It is what it is, but
I actually like graphing stuff.
No, it's okay. I'll
it's
take
kind
it
of
from
relaxing.
holiday
It's like I would.
It's relaxing compared to full-out calculus, right? Fair enough. Okay. So, use the table of values below to sketch the differentiable continuous function on the grid. So, we're going to plot those points, which you guys are already starting to work on, right? Differentiable continuous function on the grid. That means when you get those points plotted, you're going to connect them
Without taking your pencil.
without taking your pencil out in a smooth curve. Yes? No cusp, no hard points, because it's differentiable. I'll meet you in the end.
I do feel pretty calm right now.
Nope, that's wrong. Yep. That's not bad.
New balance.
17 is 14.
That's right. It's like something's not right. I was like, why, when I'm looking at my notes, do I not have it going back down? Okay. I, in case you didn't figure that out, saw 17.4 is what my eyes mistook for. Okay, there we go. I don't know why it's so much harder for me to graph up here, but it is. So, okay.
It's hard for me to connect them because I don't see like the curve.
Is it worth redoing for that?
You had a math on the AP Calc test, or not Calc, AP Physics test that I botched so bad. So everything just blurred together.
Looking at graphs on the AP Bio test was horrible.
Okay, we're going with that. That is not, great. Well, I'm looking at where we're going to have to do some things, and, well, it could be rough on mine, but that's all right. Okay, it looks something like this, right? It's continuous. It was smooth. You guys didn't do corners, right?
No.
Right.
Try not to.
Try not to.
Rounding out.
Okay, rounding them out now, fair enough. And again, that's, how do I know that?
Because it's differentiable.
It's differentiable. Differentiable is going to mean smooth. It's not going to mean the hard corners.
That's still a hard.
Why do they include the word continuous? It's differentiable, no, it's continuous.
Fair enough. The continuous is unnecessary.
It's assuming we've forgotten that part
But-
of already.
Yeah, and that is what you have to remember is you see the word differentiable, you assume continuous. Now, if you see the word continuous,
Don't.
that doesn't mean differentiable. So differentiable is the key word to see here. Okay, all right, for A. Find the average rate of change of g of x on the interval 2 to 9. What am I finding? A rock. That's secant. On the interval from 2 to 9 says I'm looking at I didn't look at what the values are, but basically it's the y minus y over the x minus x, right? I wrote it on mine as f of 9 minus f of 2 over 9 minus 2 until I get the actual values in there. What is f of 9?
11.
F of 2?
4. 7 over 7.
7 over 7, which is 1. Okay, are we good there? That was easy enough. Average rate of change. Just finding the slope between those 2 points.
Is it bad that I drew the line?
Huh?
Is it bad that I drew the line?
Not necessarily. I'm trying to remember if we have it or not. If we end up drawing this in. Because I do have some lines drawn on here, so. What was this one between? 2 and 9. Do I have this one? I do have it drawn in. Do I have to draw it in later? Or did I just choose to draw it in now? I do have it drawn in. Because it's going from what, that point to that point? So what's your secant line going to look like? I'm not going to be able to draw this one. Nope. Miss.
That's closer.
I say it's closer. Stopping there.
And you can see that it's going up 1.
Yeah. Oh, it is kind of. I did kind of make that. Okay.
Good enough.
Are you ready for part B?
Yes.
Is g prime of 6 equal to the slope of the secant line from part A? Justify. So, we're trying to ask, is g prime of 6 equal to, what's my slope in part A? 1. That's my question. Is g prime of 6 equal to 1?
Yes.
To me, it looks like it on my graph.
How do you find g prime of 6?
It's the secant, or it's the tangent line.
So you did need to draw that line. No, you didn't.
You can.
Maybe. I don't know.
This is where my graph is bad in just the wrong spot. Oh well, we're going to make it happen. We're going to make it work. Now, here's the deal. Okay, so to find g prime of 6, you're trying to look at the slope of the tangent line there, right? And trying to look at what I used.
It looks like it is, but
So right there, that's the point 612, right? And then, okay, I need some. Okay, so this was 911 that we already had. This was our 24, yes? Now, this point right here is going to be our 612. Now, the tangent line. And I do think, I don't know, there might be something said, because Sophie made the comment about, well, looking at mine, because mine, I feel like mine's going to angle down a little bit more.
Oh.
As I said, mine's not drawn great, though, either.
Mine isn't.
I'm not crazy about how mine's drawn. Okay.
Mine was down.
Yes.
Could you also do 7 minus the 13 minus 12 or 7 minus 6 with that?
Is that necessarily going to give you the slope of is that the tangent line, though? I don't think you can use those 2 points to get a tangent line. Does that make sense? So,
What about this 4 and 7? Because you 6 or 12 and 20.
what are you talking about, 4 and 7? Oh, again, that's not going to be, because if we're doing that, then we're drawing, I'm going to erase this, but then we're doing that line there.
Oh.
That's very.
And that's definitely not. Okay. Now, to do 1 point next to it, maybe, but see, this is going to, if I draw something like that, that doesn't really look like it's going to end up being parallel. And again, I get it, based on how it's drawn. Okay. That's a tough one there. What did I hit? Did I hit anything? Yeah, see, and
So,
in my notes, I have it hitting 4, 9. It's one of those things that it's close, but the argument would be not quite. Okay. In mine, if I have it hitting 4, 9, and this is why when Doug said, oh, is it bad that I drew that line in? Well, now I'm looking ahead at this one. No, it's not bad. So if I use I'm going to say F because it's a different piece, but the idea of F of 6 minus F of 4 over 6 minus 4. So that's doing 12 minus 9 over 6 minus 4, which is 3/2. And does 3/2 equal 1?
no.
It does not. Now, what's my justify? My justify is showing that work there. Okay. So if you're going to say that it is possible, then you need to be able to justify that and show the work that reflects that.
So we could just do 13 minus 12. 7 minus 6.
Yeah, if you are doing that, here's what I'm going to say there. And let me pick a different color for a moment. I'm not leaving this on here. But if you're having it go through those 2 points, it's not going to be tangent at this point. It's going to be tangent in between those points. Does that make sense?
So if our graph is just slightly different to where it does have 1/1, but we have the math to like prove that, will it be counted wrong or?
I would like to think it would be not quite so debatable.
Okay.
Does that make sense?
Yeah.
Like I totally get the
Mhm.
this one is a close call. It's a little debatable.
Mhm. Okay.
But I would like to think it wouldn't be quite so close there.
Okay.
Okay.
Mhm.
Okay. You ready for C? Does Rolle's theorem apply on the interval 4 to 9?
I would know.
They have the same Y value.
It does for 4 to 11.
Okay. So right here at 4, what do we have? We have, oh, I didn't realize there's still an orange. Okay. We have 4, 8. Over here at 9, we have 9, 11. So Rolle's theorem does not apply because the y values are not the same. And so there's a couple of different ways we can say this. Can you see the orange when I write in it?
Yep.
So one good mathematical way to say this is f of 4 is not equal to f of 9, because that was one of our, in order to use Rolle's theorem, that has to be true, right? F of 4 has to equal f of 9. It does not. The other piece we can say here is that, so f of 9 minus f of 4 over 9 minus 4 will not equal 0. Okay, these are things you can use on free response justifications, right? Like, can you use Rolle's theorem here? Well, yes I can, no I can't. There's my no. Okay, the big obvious thing of the endpoints aren't equal. Okay, is there another interval where Rolle's theorem does apply and justify?
4,
Yes.
11, 15.
And 11 and 15.
Okay, so if I look right here and I'm drawing,
No. 4 and 11, yeah.
it goes through 4 and 11, or it goes through 11, and it goes through 15. So now, technically, we could say that there's 2 intervals there, because there's 3 points, so there's 2 intervals there. So officially I'll say yes. Rolle's can be applied on, let's see. She's been using interval notation here, hasn't she? So I could say, what do we say? 4 to 11, or 11 to 15.
About 4 to 15.
I'm trying to think about, because I don't have that one in my notes. I totally get the question. Continuous, differentiable.
There's no match or minor between 4 and 15.
Technically, there's 2 between 4 and 15. That's the thing. I think the idea, I don't think it would be wrong to say 4 to 15. But I think breaking it down to the smaller intervals, because we're looking at it guarantees an extrema. And it gets a little awkward there where you have 2. Okay, so I'm not 100% sure on that, but that's my reasoning there. Okay, now, why is this 4 to 11 and 11 to 15? And that is since the slope of the secant line would be 0. Okay, and then here's the other thing. Besides the fact that their endpoints have to be the same, or the slope of the secant line is 0, the graph has to be continuous and differentiable. Yes, is my graph continuous and differentiable there? That would be something to also, mention. So G is continuous, and
Bless you, bless you. Okay, that's enough.
that was more than 3, wasn't it? Continuous and differentiable on the 4 to 11 and 11 to 15.
So do you have an or? Would you have an and instead of or on the rules, the first part?
I probably should, because it can be, yeah. Because I just used or then and, didn't I?
Mm-hmm.
That's not very agreeable. So yeah, because it can be applied on both, so I do agree. Better grammar would be and. There's a reason I'm a math teacher and not a grammar teacher, though.
There's a reason I have an A in this next class and a C.
I feel bad.
I drive one of those cars. That seems like a fun car to drive. Just go speeding down the road. Not on a country road though. I wouldn't want to mess up the car. I'd be so scared to drive on a country road.
a sports car?
Yeah, I wouldn't
I
want to
mean,
like.
if it's a rental, you have good insurance.
I just no matter what, I'd only want to drive it on just flat land.
No, it's red.
Is that orange or red?
Red,
Red?
orange.
I feel like it's, I mean, I do feel like it's
Yeah.
like that.
That's
Yeah.
Yeah.
I feel like it's not red, not orange. That's not a Charger.
Stetson's coming.
Okay.
That's a Ferrari, I think.
Okay.
Oh, I was gonna say
Wrong
it was like a
color.
Lamborghini.
It looks fine.
Lamborghini?
My brain went to Lamborghini too, but I don't even know what a Lamborghini looks like. All I know is it's not your typical
I've never
like
seen
car,
one.
normal
so-
sports car that we're going to see here
Mhm.
in Tipton County or Howard County. Like,
Either one.
Okay. Example 2. Do we have time? Let's try it. Let f be continuous. Given, let f be the function. My gosh, where am I? It doesn't say continuous at all. Okay, let f be the function given by f of x equals x squared plus 2x minus 3. Find the number c that satisfies the conclusion of Rolle's theorem for f on -3 to 1. Now, what?
So we won't have this difference.
Technically we do.
Why?
Visualize this graph.
That's the problem.
X squared. It's just a.
Okay, and this is where, in pre-calc I tried to teach you guys that basic graph knowledge, and I know you guys know this one, but this is, they expect us to know things at this point in our lives. Whether we know them or not, they expect it. And they expect you to be able to look at f of x equals x squared plus 2x and minus 3 and be able to analyze, is it continuous? Is it differentiable?
It's a crap.
It's a problem. And here's what I'm going to say even broader, is it's a polynomial. Anytime you just have regular everyday terms like that, added and subtracted together, you can justify in a calc problem that it's a polynomial, so it is continuous and differentiable. You don't even have to get specific, it's a parabola. Okay? So, now, what I'm going to say with this is before you start this problem, yes, we need to discuss with ourselves at least, does this work? Can we even use Rolle's theorem? And I'm going to say f is continuous and differentiable on -3 to 1. And I'm going to say, since polynomials are continuous. Okay? So that's kind of the first thing we have to think about there. When you talk about Rolle's theorem, mean value theorem, you have to check that. How do I know? What information did they tell me? Because they're going to pop some up that you're going to say, oh, wait, I can't do this. It's not continuous. It's not differentiable. Okay? Now, what do we know needs to happen?
Why is each other? So slope equals 0.
Okay? So we need our endpoints to be the same so that the slope, and we need the slope to equal 0, yes? Okay, did this in not the order my brain was doing this in. So, okay, how are we going to find the slope here?
Differentiate.
Take the derivative, yes? Okay. What's f prime of x?
2x.
That's old news, right? And what is this supposed to equal? 0. If this is Rolle's theorem, it equals 0. So do some solving. What do we get?
-1.
Are you guys with them? Subtract 2, divide by 2. X equals -1. Okay.
So Rolls doesn't have one.
What?
Did you say Rolls doesn't have one?
Yeah, it does.
No, it does so far.
-3 is between.
Well, okay, so here's, okay. So first of all, it's continuous and differentiable. So I know I can start talking about Rolle's. The point where the derivative, or the slope is going to be 0 is at -1. Is -1 in this interval?
Yes.
Yes. So that's good.
Have to equal 0.
Well, this is just the point where the slope equals 0. Okay, so that
at
is,
x equals -1, the slope equals 0. The slope
Yes.
right,
Oh,
right,
you said it equal to 0.
right.
Makes sense.
Okay. Now, the other thing we have to check though is, are my endpoints the same? And this is why I don't know why I have it in this order. I would have done the other order in my brain, but what do you know about the endpoints?
Do you plug in the endpoints?
Plug in
Yeah.
X,
F of -3.
Should be 0.
9 minus 6 minus 3 is 0. F of 1, 1 plus 2 minus 3,
0.
0. And that's saying right there that my endpoints are the same, yes?
So it is.
So, I mean, we basically, and officially it says to find the number C, right? So if we're trying to find the number C, we are looking for where f prime of x is going to be equal to the slope of the secant line. Well, what did we already find f prime of x to be? That was the, well, 2x plus 2 for a moment. Slope of the secant line. How do I do slope of the secant line? That's when you're going to do f of -3 minus f of 1
0.
over -3 minus 1. Regardless, we know that to be 0, yes?
Yeah.
Because f of -3 and f of 1 are the same. So that's going to be 0. You solve that.
Did we already do this though?
Well, and that's, and this is where I almost feel like, could we have left this part out? Very possibly, now that I think about it. Okay, this was more seeing, is there a value where the slope will equal 0 in that interval? Okay, this is necessary, right? Like, we've got to talk that, we've got to talk this. This is actually the find it, which is what we've kind of already done. So, what do we know at this point? Therefore, C is -1. Okay? It's the idea that if you think about the graph, it is a parabola that has points at 1, 0 and -3, 0. And the idea of where is this? Right there. Okay?
Then
That is your f prime of -1 equaling 0. Okay? So, okay guys, we've got what, 4 examples to do tomorrow, I think?
Yeah.
A little bit bigger examples. Remind me, also, we can talk, I can show you your test. I jumped right in today and forgot about it, so.